All right, we are just about ready here to go live. Let's make sure I have everything muted and we'll get going. Welcome, everyone, to Mark Voids a Warranty. I know, it's been a week already. Doesn't time fly? Well, we've got some exciting things for you today. Picked up during Amazon marketing week. I forget what they call it. But anyways, we've got something called a Dash Smart Shelf, which allegedly the way it works is you put this thing in your pantry or on a shelf or, whatever, and then you have your product on it, a bag of food or whatever. In this case, I'll use a staple gun. And it knows how much it's supposed to weigh. Well, as you use the product, for in this example, staples, the number dwindles and the weight decreases. And when it reaches a certain amount, it will contact Amazon and it will order more stuff for you. So you never run out of stuff. For those of you out there that like stuff, that's how you get more of it right here. Now, on the off chance that that isn't exciting enough, if we have some more time, I've also got this little Echo module that you plug in and you can talk to it and it does stuff. And it's got this little add-on USB module. It just depends on how time goes. We'll see. I might save this for a future teardown. I don't think it's going to be too exciting. But this particular module looks like it might be glued shut. You know what that means? That's right. Mark Smash. So anyways, thank you for joining us. Those of you out there in TV land that are with us right now, feel free to chat, ask questions, leave comments, say nice things. Got a cat. I mean, who doesn't like cats? So anyhow, with that, let's get going and see what we're dealing with here. We'll take off the protective plastic. I mean, I don't know about you guys, but this stuff makes a really great toy. You can do all sorts of stuff with it. Plastic hand puppets. Rawr. Put a couple googlies on there, googly eyes on there. Maybe you got something. I don't know. All right, so the first thing, it's got one of these little plastic retainer clips so that it comes with batteries. That's kind of cool. And all you have to do is just remove the clip and it's live. Well, we will save those batteries for something else. What, I don't know. So one of the first things that I notice here is there's really not much to this. It's a shelf. There's a piece of plastic that's floating up top. A micro USB port for something. What that something is, I couldn't even begin to tell you. You've got batteries on the bottom. Looks like a spot for a label on the front and a button that you can press and it will do things, probably linked to your phone. I'm not entirely sure. Also, we've got these big 4 plastic rubber mats to help distribute any force and hopefully keep this bottom part level. Now, undoubtedly, there's going to be some case screws, and I bet they're going to be hidden underneath this stuff somewhere. I'm probably going to have to peel them up to find out. Oh, well, what are you going to do? Yep, 2 screws there. We're going to speed things up, get rid of these rubber mats, get the spudger underneath it. I probably wouldn't have found, I mean, now that I know where they are, but I probably wouldn't have found those by probing and trying to drill through to get them. I would have expected them to be more in the corners or something. The only thing that's concerning me so far is that there are so many case screws. that's leading me to believe they're not in fact case screws, but they're actually holding in the bridge sensors. But we're not going to know until we start going. So now I've not done anything so far that is unfixable, right? Everything so far can be put back together. I'd have to get some new adhesive, but even some spray adhesive would probably save me at this point. It wouldn't be ideal, but it would work. So I'm going to assume that the screw, the one of these that does not look like the other, is the case screw. And hopefully leave those bridge sensors connected. But I don't know what we're getting into. I could be wrong. Oh. We got it. Okay. So on the part that is the scale, it looks like we just have 4. Are they magnetic? Yeah, they're magnetic. Barely. But we've got 4 steel posts that in turn push down on these stress strain sensors. And these sensors go out to, all these different wires, and then they come and meet together to find a circuit board underneath this piece of plastic, which is indeed glued down. Okay, we're making progress. So hiding inside that case is this little circuit board, and it's got some things on it that we're going to want to look at. That'll be fun. Oh boy. We've got a tag connect. Oh, what would be the best way to get this out? So, I don't know if you guys can see it because the lighting isn't perfect, but there's a screw there that I'm eyeballing. The issue is that this is going to be in the way. So I was seeing if there's, just kind of taking a look around and seeing if there's anything else I can do to take this apart to remove that. It sure does look like that comes off. So we're going to pop these. Now, a minute ago, I used a technical term. I called those bridge sensors. That doesn't have anything to do with the type of bridge that you drive across on your car or walk across, or bike across. It has to do with their sensitivity and the electronic circuit that is used to record changes in it. You might be able to hop on the internet right now and Google something called a Wheatstone bridge. And it's a type of circuit that is incredibly sensitive to very, very minor changes. Used in a lot of things like digital multimeters. Okay, we got something going here. So removing those other screws did allow the case to come free, and we've got a micro USB. And I am just going to see if I can't get that out of there. So we've got one less piece of plastic to deal with. Okay. Now we've got complete access to everything. So that's good. So that's pretty neat. So the electronics here are going to be responsible for sensing changes, tiny, tiny changes in these sensors. Usually resistance, voltage, sometimes current is another thing that is sometimes recorded. But all that you've got going to these things, each one has 3 wires, it looks like. And before we destroy it, I just want to see if those things will, if I can at all remove them. We might play a game here with them in a second. All right, so underneath there are, where are we here? So underneath each one of these sensors, there's other pieces of metal that act as mechanical stops to prevent, you know, overextension of this stress strain sensor. Come on, big guys. There we go. And one more. One more. So this is pretty typical setup of a lot of different scales, anything from your bathroom scale to, you know, this type of electronic scale is going to use multiple sensors. That way the load is theoretically distributed to each sensor, so they'll have a lower dynamic range that they have to deal with. All right. Almost there, guys. We're almost there. Thank you for your patience. By the way, again, anybody out there that's joining us, if you have any questions as we go through, feel free to ask them. There is a lag of, I don't know, 20 to 30 seconds in the video, unfortunately. But I am more than happy to field questions. So the next thing I'm looking at, we've got everything disconnected except for this little 6-volt power supply. And I was hoping that it was a separate piece that I could pop out and we could maybe scope this thing. But it looks like it's all molded in together. So if we do an experiment here in a minute, and I don't know that we will, but if we do, I think I'm just going to hook that up to a power supply. Okay. So, plastic housing. This is all unremarkable stuff. And not really what we're into looking at today. So, let's start with our, we'll start with our USB and work our way in. All right, Mr. Microscope, time for you to do your thing. We've got the micro USB, and I'm trying to figure out what we've got going on here. It's interesting. So we've got route outs, but it doesn't really look like, well, I guess maybe those can go in there. I was just wondering if maybe they designed this for multiple micro USB connectors, but that doesn't seem to be the case. So they just have some sort of a recessed mount. Typically what you'll see is that you know, there's pins that protrude up out of each one of these holes, and I just don't see that here. That doesn't seem to be the case at all. And then we've got pads for parts that don't seem to be populated. And then, okay, so what I'm looking at right now is why they, why they ended up not using them. So I'm guessing this was meant for a resistor of some sort. Typically you'd have some TVS diodes, but that's just a weird pattern. I don't know what's going on, to be honest with y'all. I mean, part here, part there, part here, part there, part here, part there. And they're tied to a copper pore. So I wonder if these aren't for maybe some sort of a case resistor, something to connect the overall ground to something else. One thing I do like to see, you'll see all these vias all over the place here. That keeps these copper pores from becoming radiating elements. So that's all good stuff. And they use multiple vias where they could. And they appear to use all through-hole vias. So that really keeps the costs down too. Anytime you upgrade to a blind or buried via, you're increasing lamp cycles and you're costing everyone money. So, interesting. Okay, so it looks like they put these in and then maybe during testing they discovered that they could get away without them. So they didn't. And rather than paying for a connector, they just had their assembly house solder the wires straight to the board. That is one way to save money. It does make repair a little more difficult, but it's, I mean, they're just wires on boards. It's no big deal. It's totally doable. Interesting thing, though, is that there's no shielding or anything on those USB cables, so there could be some EMC concerns coming out of those. You know, they're just long wires. But, you know, presumably this passed EMC compatibility testing, so must not be a problem. We've got a couple test points. And here, they take these wires and start treating them like a differential pair again. That's kind of funny considering they just, you know, ran random wires, unbalanced wires out there, and then they start caring about signal integrity. Okay, that's cool. All right, so here I see some labels with D in front of them. So these are electrostatic discharge diodes, TVS diodes that are used to prevent static electricity from coming in on the USB line and shocking stuff. And then they did something that well, they did a couple things here. One, they ran a really narrow guard trace right down the middle there. I wouldn't have done that. That is just a sliver waiting to happen, or an antenna waiting to happen. I really don't know what use that's providing. I can't imagine it's providing any use at all. So I'm looking right here. You can see, okay, so coming off the TX line, you've got a line coming in, RX line, you've got a line coming in. And between those two, they just have this tiny little sliver of copper. Again, I don't know what it's doing. Anyhow, then we hit some diodes and maybe some you know, low value resistors, and then we hit test pads on a differential pair. You tend not to see that for good reason. It creates an impedance discontinuity. I mean, this wire harness creates an impedance discontinuity. But anyways, it creates a impedance discontinuity that can cause ringing, and then you're off to the races as far as noise goes. So, interesting. Here's something else, too. I wonder if we can zoom in. Or if I need to... wonder if I have something that can give you guys a scale. Let me take a quick look over here. Ooh. Okay. Is it even going to show up? It's just going to be a mess. Okay. I was just trying to give you guys a scale. So I've got this little microscope card, but it looks like the light, the reflection of the light off of it is going to not be too useful to us. Anyways, what I was looking at was, you know, there was a trace that was much smaller than it needed to be. See if we can find it again. Connect. So here's some vias. They're doing some amount of net crossover for these guys. And I was just looking at this really, really tiny one that is tiny for no apparent good reason. I don't know what it's doing, but the reason I'm concerned about it is that if there's any slight little bit of misregistration and this via hole gets shifted up, it can cut off that trace. Now, initial glance is that this is, you know, these drills are very well registered. So that's probably not a huge concern. But there's just no need for that trace to be so small. It could lead to a future issue. And we've got what appears to be flux, schmutz all over this board. So they didn't bother having it cleaned. That's going to make my friend Mike so very sad. Mike Conrad does Aqueous Solutions. He does board cleaning, and he likes to remind people, even if you have no clean flux, doesn't mean you have a no clean board. There could still be issues with it. So I'm just looking around for other things that are interesting. We've got just test points all around. This set of wires is all connecting the bridge sensors, USB, so they've got all this stuff on just one side. Keep it out of the way. Lot of vias that are doing some stitching here. So here they have a copper exclusion for whatever reason. This is at the edge. They decided they don't want copper there. Is that an antenna? Did they make an L-shaped antenna? So here's what I'm looking at, right? We've got a long run of copper here in the corner. And they connected it with a diode. No, is that a diode or does that say Q? Q32. Okay, I need help with this one, guys. Anybody out there knows what's going on with this copper sliver? It really looks to me like maybe they... But it's an antenna tied to ground? Oh, I don't get this at all. This certainly has a use to it, but what's that use? And why the label Q? This is a tiny part. This is like a an 0201, maybe 010-005. I'm not really sure. We need a scale to know for sure. But that is a seriously small part. So what is it doing? And if it's tied to ground, is there anything feeding this on another layer? I don't know. Weird. Weird, weird, weird. Maybe we'll figure out some more as we keep looking around. So again, I'm just looking around the board, looking for things I like, things I don't, things I might do differently, things you might do differently. So coming off the middle of this IC, no, that can't be a differential pair. I don't know what that is. So it looks like, I'm guessing that's a ground, and maybe it goes underneath and hits a thermal pad. some of the things that are weird, like see this little via to a sliver that goes nowhere? I mean, that's not a micro via or anything. Or it sure doesn't look like one. If they did manage to hide something under that, that just looks like a mistake. I don't know what that's doing. Why do you have a via coming up connecting to what appears to be a ground pour, I mean, the world's smallest ground pour, and not doing anything? I don't know. I'm guessing that's a boo-boo. What's this? Is that just schmutz? That's just schmutz. So again, you see multiple vias tying these various ground pours together. That's good. It's also good if you can to use, that was probably me scratching around with this pick. I'm not going to blame them for that one. It's also good to use multiple vias for component ties if you can, if you have room for it. And you don't always have room for it, of course, but it's just gives you a little bit of extra insurance in case a via fails. You know, if there's a drill misregistered or whatever. One thing that always I do always like seeing are using multiple vias whenever you can. But without knowing what's going on here, this number of vias on a trace this small seems excessive. Even for a very, very high current carrying trace, which I doubt this is, doing that many tie-ins that close together, I don't know that that provides much use. We'll see in a minute if we can't flip over and see what's going on. You've got inductor maybe. 2D code for tracking. This is, if you've ever seen one of these are called fiducials. This is for locating the board. You usually need 3. I mean, you can get away with 2, but you usually want at least 3 on a board to figure out where stuff is. All right, so here we've got a crystal that is feeding the clock on this. A couple of little tiny caps to help balance the crystal load along with a ground tie. And they're worried about this thing being noisy, so they've surrounded it with a ground pour. And they've tied that ground pour in with multiple vias. It would be good if they could have squeezed a little bit more copper into this area. They definitely needed more copper in this area. That is a manufacturing yield issue waiting to happen. So if they could have shifted this over to the right, a mil or 2, that would have given this a mil or 2 insurance. I want to show you these programming headers here if I can figure out where they are. So this is my fencing, so it's to the left of the fencing. Here we go. I like these. So there's a company, and I believe it's called Tag Connect, that sells pogo pin probes that connect to these things. And essentially what it is a programming header. So you don't have to pay for programming headers, right? That's smart. A little 6-pin through-hole part, or even a surface mount part, it's going to stick up, it's going to take up space, but more importantly, it's going to cost you money. Well, if you use these Tag Connect things, right, you get this, you buy this device, and they're not much, they're like 30, 40 bucks. It's really not much. I don't know the exact prices, by the way, and I'm not shilling for the company. I just like their idea. Anyhow, you take it, you poke it down, there's 3 registration holes, so you get everything lined up, and then you can program your device. Easy peasy. And they've got multiple ICs, so they have multiple tag connects. So every time you see one of these guys are saving the cost of a header. And it adds up, even on small batch orders, but it definitely adds up if you're Amazon. All right. I just noticed something. They just went hog wild with their via stitching here. And what they're trying to do is connect, basically create a wall with vias to prevent any signals from coming out between the plane layers. And then we've also got, well, let's see what we can figure out. So we've got another one of those copper things coming off ground. It's got to be an antenna of some kind. That would make sense. And then surrounding that, you've got all of this via stitching. And the goal there is to try to prevent, again, any signal from coming out between the plane layers. All of their RF lines, too, they seem, well, why did they stitch heavily on this side but not this one? Not that it would matter that much, but interesting. So they've created other via fencing here. I'm just wondering why they didn't extend it right in this area. And I wonder what that was supposed to be. Oh, here's something that never happens. Revision 1. I don't believe you. No. How did you guys do all this work with all the RF and the balancing and everything in one revision? That's nuts. So typically what you see, you know, when you get RF lines is you can do all the math in the world, but at some point you have to actually balance this thing in the real world. So one of the things that'll help with that is something called first article service. So with first article service, you get your boards, you know, maybe you order 10 of them, or I'm sorry, let's say you order 1,000,000 boards. I don't know, you're Amazon, you can do that. Well, you don't want to make all 1,000,000 boards at once. You want to order 10 of them. And you get the 10, and then you start doing your pi filters and everything, and you get your signal balanced. And then, this is an antenna. And then you order the rest of them with parts that you know work. All right, so down at the bottom here, we certainly have an F antenna. I mean, you can kind of make it out there, which then really leads me to wonder what the heck these things are. Commenters, help me. Help me, help you. Help me, help you, help me. Another unpopulated part, but anybody's guess what that might be. But you can see they're really worried about EMC around the RF section of the board. So here they did a double wall via fence. It's just weird. And I'm sure they have simulations that told them to do this. But why they did single fencing in some areas, doubles in others, I don't know. I would just say at that point, just go nuts. You know, copy, paste. Rinse, wash, repeat. Okay, let's take a look at the other side. So right now, we've got pretty much all the components on one side. Oh, not pretty much. We have all components on one side. All that we have on the back side here are just the bottom sides of vias. Now, that's a really smart decision because that keeps the cost down on your board by a lot. Because that's only one trip through the pick and place, one trip through the reflow ovens. Or is that a balun? It is. Okay, so balun are balanced to unbalanced matching ICs. I don't know anything about this one in particular, but that certainly seems to be what that is. 0 ohm jumper. So this could be a jumper, or it could be trying to get rid of some high frequency RF. High frequency RF doesn't like going through all of the impedance changes that you get at sharp right angle turns, as you go up, over, down, so it can sometimes filter out without needing a choke, a ferrite choke. Interesting, interesting. Okay, so what we're going to do now is something new. Something we haven't done yet on Mark Voids a Warranty. We're going to look at a device under test. Yeah? You guys excited? So it's going to take me just a second, just because I do have to grab a couple cables, right? I was semi-prepared for this, and semi-not. And I've got a multimeter ready if we need it. And I've got my power supply ready, which is good because we broke off that battery pack. All right. So we've got 4 bridge sensors. We've got power. Oh man, this is weak wire. How are we going to do this? Might need to pull out my thermal strippers. Let's try a knife first, just because that's fastest. And if that doesn't work, I do have a way to strip these. Okay, that's clear. So it looks like I have access to black and red. Oh, is it going to be strong enough to catch it? Maybe, maybe. All right. All right, viewers, everybody out there in TV land, we've got these bridge sensors attached so they can hook up to power. We need to, looks like I'm on channel 2. What's going on? Okay. Looks like we need 6 volts. That's what we would get off of batteries. And energized. Now, the new thing. So the new thing that we have is the oscilloscope. We haven't been able to probe stuff before on Mark Voids a Warranty. Now we can. So we've got a Keysight power supply and a Tektronix MDO 3104 scope. So I might need a reference ground here in just a second, but let's first focus on getting you on the screen and making sure that you too can see a scope. Oh yeah, right? How cool is that? So, I mean, really all I'm showing you right now is RF noise, but the cool thing is I can even show you RF noise, right? We couldn't see anything before. All right, so I'm sharing the ground probe point, just so you know. I'm sharing the ground probe point with the power supply. I assume that's going to be the common ground. I don't know for sure, though. Now, I might need to change to a different camera so I can see the probe points here. By the way, dear listener, don't get old. Your eyesight goes. Your hands, they shake. You get grumpy. You get gassy. Oh, it's not a pleasant life. so don't get old. All right, back to electronics. So what I'm looking for are probe points for those slivers of copper that I couldn't explain earlier. But the stuff's so small, I can't really see where to probe. So let's see if we can get our overhead narrow view going, and see if I can use my screen as... So I'm looking at these things right here. And then let's see if we can't figure out if there's anything going on there. I'm just seeing noise. Very low signal amplitude. Are we plugged in? We are. My probe is auto set to that. You guys are probably wondering what's going on, and the answer is nothing, just noise. Right? Whether I touch it or not, there's really not much going on those. Now, I know the scope is working because if I hit some of these other probe points, and I don't even know what these probe points do, but they work out just fine. It's just, I don't know what those things are. Interesting, interesting. All right, let's change our ground reference point and see what there is to see. So I'm going to assume that the black wires on the bridge sensors are a local ground. And I'm going to see if I can't snag one. Let's do something. Let's get a different probe. Might just want to clamp right on it. Do I have any clamping options? I should, but maybe they're not in here. Let's see if... What I'm looking for right now is something that will let me grab on without damaging or shorting all right. So this is black. Black is typically ground. It's not always ground. You know, so this is the one potential. So we can see a slight bit of noise. Now, which bridge sensor is that? It's this one. That is interesting, but I'm not seeing anything remotely change. So there's a signal coming through these things. But as you can tell, whatever it is, I mean, I'm at 100 millivolts per division. This thing's small. Let's put a trigger on here. So what do we think that is, guys? And then the next question is, does it change as I start manually harassing this sensor? Does seem to shift a little, but not much. Let's see. Here, let me get that off of here. That makes no sense. Remove all measurements. So what do you guys think that is? I mean, okay, so there's options. It could be that I'm just picking up an RF beacon. That could certainly be it. It would make sense that, you know, I'm not seeing anything significant change on these things. So it could just be that I'm picking up RF noise from the antenna. Let's go over to our antenna and take a look. Where are you, Mr. Antenna? Oh, here. It was off. Haha. Or at least those LEDs were off. So here is our board. I wonder if I can work on the focus of that for you at all. How's that looking out there, TV land? So this is our little F antenna down here. And when I key that, I get that same noise. So what I was looking at was simply the noise from that antenna getting picked up by this antenna. Interesting, interesting. Well, let's see if there's anything else that comes up on a probe. Looks like there's a couple things. So I'm just probing different pins to see what comes up, and you can see that same signal pattern appear over and over again. I mean, it might roll because I don't have, depending on what the trigger level is. So that noise from that antenna is getting picked up by my, it's not necessarily in the board, but it's certainly getting picked up by my probe. And I'm just looking to see if there's anything else to see around here. Anything of interest? Right now, I'll admit, I am not that excited, but you never know. Is that a probe for a clock? Let's see. Nope, same noise. Well, TV land, it looks like that might be something where I need to play with it off camera and see if I can figure out what these test pads are doing. They could, I mean, they can't all be voltage and they can't all be programming test pads. So all I'm doing right now is just going around and hitting different pads to see if anything shows up. And so far, not so much. Other than that noise that we're getting that is presumably from the antenna, I'm just not seeing anything. Even our little bridge sensors, I'm not seeing anything. So probably what I'm going to need to do is pull out a high-resolution multimeter and see if I can detect it with that. Unfortunately, I don't have any way to put that on the screen for you yet. Ha ha ha. All right, so with that, looks like I have stopped making forward progress for the moment. So, I mean, it was kind of interesting. We got to take a little bit of a look at what's inside a scale. And, you know, obviously there's lots of stuff. The main body of it are your 4 bridge sensors. And then we've got ICs that interpret the information. An IC that acts as a network processor, you know, that controls the Bluetooth and all that other good stuff. And that's pretty much it. I don't know, there's 3 big ICs on that board. Part of me wonders if they in fact need all 3, if they couldn't have figured out how to do it a little easier. But I'm sure they got a great deal and doesn't really matter. I need the microscope to make out those logos, but I'm thinking it's a MediaTek. I can't tell. Maybe you guys can. Oh, there it is on the monitor. So we've got a MediaTek Holtec, nobody I'm familiar with. And is that a TI logo right there? In the bottom right? I need a microscope. I can't tell. Anyhow, that was Mark Voids a Warranty. So I hope you enjoyed it. I know I did. I always like taking stuff apart and seeing what there is to see and, you know, what people might be able to do better next time. And we did find a couple things, a couple interesting points, but that is an Amazon board. Nice and rectangular. Makes it real easy to array and, you know, maximize your panel yield. So that's cool. You can see a couple tooling holes. One here, one there, that they designed in either for, I mean, why they designed tooling holes in addition to the mount holes, I don't know. But maybe that was so they could keep everything aligned during reflow. I don't know. But I mean, it's a good design. It obviously works. There is more to learn about it, but not today. Before we go, though, there is something I would like to share with you. I've got an issue and I need your help. You see, back behind me, right here, I've got this ginormous lens. This thing is huge. Look at the lens element in this thing. It's the size of a dinner plate. Now, we're at about 316 subscribers. We're growing. I mean, we're a good couple a day. It's fine. It's no big deal. But I want to get to 500 because when I get to 500, I get to take this apart. And the only way we get to 500 is if you tell your friends, tell your neighbors, tell your friends' neighbors, tell your neighbors' friends. Tell everybody you see about Mark Voids a Warranty. And once we get to that 500 mark, that bad boy is coming apart. Yeah. So I need your help with that. Tell people, tell people, tell people. And join us next week for Mark Voids a Warranty, where I'll take something else apart. You never know what it's going to be, but I'm going to break it. It'll be fun. As always, if you have any needs for boards, if you have any questions, you can reach out to aapcb.com. I'm mhughes@aapcb.com, or you can just email sales@aapcb.com, and they'll reach out to me. However you want to do it, we'd just love to hear from you. I hope you like it. If you have any thoughts on how to improve Mark Voids a Warranty, or any ideas for teardowns or anything along those lines, reach out. I'd love to hear from you. So with that, that's the end of it. Hope everybody has a great weekend, and we'll see you next time on Mark